All right, so we've got two ways of approaching projectile motion that I want to review before we go ahead and do our homework problem. So first, we're going to have a projectile launched like this at an angle theta, and we're going to launch it. So we've got theta, and we've got v naught. And what we're going to say is one way of approaching these formulas is that we can say, well, in the y direction we got negative 1/2 gt squared plus v naught y times t plus y naught. And Vy equals negative gt plus Vy naught. And then finally, Vy squared equals V naught y squared plus 2g times y minus y naught. It's in the y direction. And then in the x direction, we'll have the formula x equals V naught x times t plus x naught. So this is one way of approaching projectile motion. Now, there is a second set of formulas that we use that is based on solving these for known and unknown variables. And when I actually do that math, let me just double check. So I'm going to derive the math here. So these are actually the formulas you have to memorize. And I'll actually put a blue box around this right here. And I'll actually just kind of be careful. Erase this little part here. And, we will go ahead and derive the formulas for projectile motion that we did a couple days ago as well. So you're going to use those too, and I'll put a little blue box around that once we've come up with them. So I'm just going to do the work to derive them here. So this is the part that you should have done on another piece of paper on that other worksheet that we did in the previous video lecture. And let's see, so we've got Vy equals negative gt plus V naught sine theta. And of course, when we isolate time, we're going to get V naught sine theta divided by g. So we double this to get the hang time. So that's 2 V naught sine theta divided by g. That's one formula. Then to get the height, that's V naught squared sine squared theta divided by 2g. That equals y, the height that we get to. So that's V naught squared sine squared theta over 2g. And then to get our range, that's going to be V naught cosine theta times 2 V naught sine theta divided by g. And so when we actually work this out, this works out to V naught squared times the sine of 2 of theta divided by g. So I get my range is equal to V naught squared sine of 2 times theta divided by g. Whoops. So x is, again, V naught squared sine of 2 theta divided by g. And then this is our second set of formulas right here. You have to memorize all of this for the exam. So I'm going to go ahead and use these formulas now. So a golf ball is hit at an angle of 30 degrees and goes 150 meters before hitting the ground. With what velocity was it hit? So let's go ahead and do that. So I'm going to assume that 150 meters means 150 meters horizontally. So we'll make this x naught equals 0 and x final equals 150. So when we do that, we're going to say that using the formula here, for the range, I'm going to say that x equals V naught squared sine squared, whoops, let's double check, V naught squared, sine of 2 times theta divided by g. And our goal is to isolate V naught. So we're going to get g times x divided by the sine of 2 theta equals V naught squared. So we're going to plug in 9.8 times 150 meters divided by the sine of 60. We put all that under a square root and we'll get V naught. And when we do that, we're going to end up getting a speed. of 41.2 meters per second. Now, problem number 1 is exactly a copy of this example. So you'll go ahead and use this to help you solve this problem here. Now, problem number 2, we have a volleyball. It was served at the speed of 15 meters per second. And it lands here at x equals 18, starting from a position of x equals 0, and it was launched at 15 meters per second. We want to know the angle that it was launched at. Now, we're going to go ahead and take a look at our angles and our problems and our formulas. So backing up here, we can actually take a look at this range formula once again. So we're going to say that x equals v naught squared sine of 2 theta divided by g. And we're going to go ahead and we're going to try to isolate this theta. So we're going to say gx over v naught squared equals sine of 2 theta. And then therefore 2 theta is going to be the inverse sine of gx over v naught squared. So we go ahead, plug in our numbers. So 2 times theta is going to be the inverse sine of 9.8 times 18 divided by 15 squared. When we get that, we're going to get 2 theta equal to, gives me 51.63 degrees, and that gives me theta is going to end up being 25.8 degrees. Now, one of the things that we worked on our worksheets is if this gives us a range of 18 meters, it turns out that 90 minus theta will also give us the same range. So we actually end up getting 2 answers, 25.8 and 64.2 degrees. Now for the third question. We have a basketball player shoots a ball at the level of the basket. And shoots an angle at 65 degrees. And I think what they're trying to say is that they shoot the ball. So we're at 4 meters here. The height is 3.05. And this is x final, y final. We have x naught equals 0 and y naught equals 0. And we are told that we shoot at an angle of 65 degrees. And we want to know the speed at which we shot the ball. So I guess what happens is that this thing goes into the air and lands at the basket. And we want to know the speed that we shot the ball at. So that's what we want to go ahead and calculate. Truth is, I'm not entirely sure how to get started on this completely, so I'm going to give you some suggestions. I'm going to try these. I want you to try to get an answer, because by the time I put it in the Google Doc, I will have the answer, and you'll need to get this in class. So here's what I suggest we do. Let's do the x formula as x equals v naught cosine of 65 times t. And in the y direction, we're going to say y equals 1/2 times negative 1/2 g t squared plus v naught sine 65 times t plus 0. So we'll just leave that out. And then our goal here is to plug in a few more numbers. So for the x formula, we'll put in 4 equals v naught. Let's get the cosine of 65. So actually we won't just get that yet. We'll just put cosine of 65 times t. So we got 2 unknowns there, v naught and t. And then in the y direction, we have 3.05 equals negative 4.9 t squared plus v naught sine of 65 times t. So here's going to be your approach. Solve for t here. Plug it into the formula here and here, and then get v naught. That's a good problem. I like that one. I didn't even make that one up. So that'll be what you'll do. Let's see. We have here 50 meters. We don't want to shoot beyond 50. We launch at 24 meters per second at an angle theta. So we want all our shots to land behind 50 meters. So if our angle is too big, it'll go beyond 50. And if it's too small, it will go beyond 50. So this is actually very much like number 1 and the example problem. So I'll leave that to you. Now, question number 5. Let's just draw a picture. So we have something at 80 meters high. So y naught is 80, y equals 0, g is negative 9.8 meters per second squared. And we're saying we land 160 meters away, so this is x. And x naught is 0. So you land like this. So you've done a problem like this before. Now, it says the speed as it left the cliff and its speed as it hit the ground. So here's the deal. Get the hang time from the y equations. Use this to get the x. So this is your suggestion. Get the hang time from the y equations, get v naught x, and then get v naught y as well. And then to get part B, so this is the answer to, so this is going to be the answer. So actually I shouldn't say A, B, and C like this. I should number these as 1, 2, and 3. So we'll make this 1, 2, and 3. So to get part, this will be part A. And then part B will be v naught x squared plus v naught y squared. So that's kind of your hint for that problem. I'm expecting you to kind of use that to get that set up. So those are some good starts. So I think that's pretty much all the problems we have to do. So I know that wasn't completely the best set of hints, but that's kind of how we're going to do this in physics. Is we're going to give you fewer and fewer hints because I expect you to get this more and more on your own.